Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering where study elaborates decoding the earth to build a better world. Guys, today we will see the important question answers related to the exam point of view which are most likely to be asked based on the orientation of rocks, soil characteristics, index properties, soil mechanics, rock mechanics and many more. Here the question which is the application oriented question related to the advancement of remote sensing and usage of remote sensing with reference to the engineering geology context. So question is of 6 mark. The describe various remote sensing techniques or sensors and resolutions with suitable illustrations. So remote sensing platforms, remote sensing sensors and remote sensing resolutions which are required or used with reference to the engineering geology point of view with reference to the study of rocks, study of soil and its index properties. So here we see the remote sensing platforms. Platforms are the carriers that hold the sensors to acquire data from the earth, satellite platforms, aerial platforms and drone platforms, or we can say that the ground platforms, aerial platforms and satellite platforms also. Second one will be the remote sensing sensors. That sensors detect and record electromagnetic energy which is reflected or emitted from the earth's surface. That type of sensors are divided into two parts basically, active sensors and passive sensors. So first will be the optical, that is the passive sensors. Second one will be the thermal, that is the infrared sensors. Third one microwave, that is a combination of active and passive sensors. And the advanced are the active sensors, that is LiDAR system. Here these remote sensing sensors are most important to collect the data and its accuracy. Then third point will be the resolution point of view with reference to the remote sensing. The data which will be collected with reference to the resolution which refers to the detail with which an object is recorded. The four types: spatial resolution, spectral resolution, temporal resolution and radiometric resolution. So basically the various remote sensing platforms, sensors and resolutions are most important with reference to its region, its features and its example, so that we can prefer the platform, we can take the sensor for that platform and we can use the resolution which is more feasible for that type of sensor and for that type of platform likewise. So here the answer for the 6 marks must have to contain these three in detail with reference to the tabulated format or with reference to the bullet points format. If possible, you have to draw the diagrams and the illustrations which are required, because our question is of with suitable illustration. So you have to draw that illustrations also with reference to some unique example. The remote sensing data acquisition procedure, which is most important, which is the application point of view, where the process flow started from data acquisition from the platform, sensors and resolutions, where platforms carries sensor and acquires data. Then data transmission, that is data transmitted to the ground station. After that we have to collect the data, that is data reception at the station, base station, data received and data recorded. Then most important point, that is processing, which is the data processing, where correction, enhancement, classification, analysis comparely work together or simultaneously work together or in the step by step procedure with reference to our objective. Then information extraction with reference to the layer point of view, that is thematic maps preparation, digital elevation model, change detection, digital surface model, terrain model, each and everything will be used to extract the data which will be processed on the basis of these three basic steps. After that we get the output, that is the application point of view or the report generation within the graphical format or in the tabulated data format, where agricultural, geological, water resource point of view, urban planning, disaster management, each and every construction domain which will be each and every construction domain will use this type of process for data acquisition as the application point of view. So here the marking scheme in the four formats, which includes remote sensing platform with illustration 2 marks, these three part. Then remote sensing sensors with illustration, these four 2 marks. Resolutions, types, definition and examples, this is for 1.5 mark or 2 marks, we can say that. Likewise, neat diagram, flowchart, overall representation for half marks. So this is actual bifurcation of 6 marks. So basically, this is the actual conceptual question for the remote sensing technique with reference to its platform, sensors and remote sensing resolutions. Most important question or the topic related to the exam point of view, that is geohazards. So question which is framed with reference to the definition, define geohazards and classify its types with suitable examples. So here the concept of geohazard and its classification, which is the actual focus with reference to the 6 marks point of view. Here the geohazards are naturally geological processes or phenomena that pose a threat to life, property, infrastructure and the environment. They result from earth materials, processes and events that occur on the or within the earth surface, which is a most important study for the civil engineering point of view, as we are the creators. So we have to understand that geohazards that are natural geological process. So what is the classification? Four types are there based on endogenic, exogenic, anthropogenic and hydrogeological, or we can say that the hydrological. So geological hazards, geomorphological hazards, hydrological hazards and environmental hazards. So four types of hazards that are the geohazards. Here we go one by one. Geological hazards, that are the endogenic hazards. They arise from internal processes of the earth. The examples are earthquake, volcanic eruptions, tsunamis and tectonic movements. Secondly, geomorphological hazards, they are exogenic. They arise from external processes acting on the earth's surface, or we can say the man-made activities, that are landslides, rockfalls, debris flows, soil erosion, as explained in the picture. Third one, that are the hydrological hazards. They are related to the water and its movement. Also we can say that the hydrogeological hazards, also the movement of water beneath to the earth surface, also we can take it here. That examples are floods, glacial lake outburst floods, coastal erosion, dam failures and many more. Then fourth but not the least, that is environmental hazards, that are anthropogenic geological interaction hazards. Here that results from human activities interacting with natural processes. Okay, means land subsidence, groundwater depletion, mining hazards, pollution of soil, water. So basically the whole classification of that hazards or geohazards, we have to be aware about it, so that our project, our site selection criteria for any type of project which will satisfy the requirement of that project effectively and safely. So the geohazards may vary in the intensity and frequency, and their impacts depends on the susceptibility of the area and the preparedness of the society. Susceptibility of the area means the activity where we have to construct, and we have to be aware about these all geomorphological characteristics, geological characteristics, hydrological characteristics, environmental conditions of surface, subsurface, soil, rock, everything. So your answer must have to follow these two concepts, that is classification in detail with reference to that four hazards and your definition. So the short marking scheme, where definition you have 1 mark, classification 2 marks, explanation 2 marks and neat diagram 1 mark. If possible you can draw any one diagram of each and every example here. Next, most important exam point of view, the 6 marks question related to the application point of view in highway projects. Explain geological mapping. Explain geological mapping and remote sensing applications in highway projects. This is also application oriented question. Here two parts, geological mapping and the remote sensing applications. Here the remote sensing data and its output based on some sources or platforms of data collection. With reference to that, we get the outputs in the layer by layer structures in the models like digital elevation model, surface model, terrain model, likewise, or we can use it for the land use land cover mapping and urban sprawl management also. So here first of all we have to see the geological mapping, that is the systematic study and representation of rock, soil structures and geomorphic features on the map to understand the geology of an area for planning and safe execution of highway projects. So what is the objective behind that geological mapping? These are the 5 objectives or 6 objectives listed below. These objectives are nothing but the applications in civil engineering or highway projects. that is route alignment, site investigation planning, material evaluation, hazard identification, design input, and environmental planning. So basically these all are the applications in the highway project which satisfy the sustainability also. Then most important workflow for that geological mapping or process which will be followed based on pre-mapping study, where collecting existing maps, reports, previous data of that site. Then field mapping, where traverse the area or locate the area or mark the area, observe the outcrops with reference to the subsurface geological explorations, altitude of substructures, collect samples for the laboratory testing point of view. Then data recording based on the lithological characteristics, structures, discontinuities, geomorphic features, water conditions, and many more. After that, we have to prepare the map, where we have to plot the data on the base map, prepare geological map with legends and sections so that we can analyze that map with reference to the further studies. And at the end, the geological mapping completed with reference to the interpretation and reporting point of view, where we have to plot the analysis findings and which provide recommendations for design and construction activity which will be commenced in coming future with reference to environmental conditions and geological conditions. Second part, that is remote sensing and its application. Remote sensing, which will be the acquisition of information about the earth surface without physical contact by using satellite and sensors. That may be a ground based sensor, aerial sensors, or satellite sensors. So what are the applications with reference to the highway project point of view? The remote sensing technique which will be used from the reconnaissance and route selection, then alignment and structural mapping, then lithological discriminations, then landform and terrain analysis, followed by landslide hazard, soil moisture assessment, material source identification, and at the end, environmental and land use planning. So basically, these are also based on some sustainability approach, where we have to follow the activity for highway project and its efficiency. Most important, the conclusion part, that is geological mapping provides detailed ground information, while remote sensing that offers synoptic and up-to-date data on the today basis or on the current ground control point basis. That integration of both techniques which ensures selection of safe, economical, and environmentally sustainable highway alignment and designs means that advantages in highway projects are dependent on that geological mapping and remote sensing applications that are used for data collection point of view also, and site selection criteria design point of view also. So the advantages, that covers large and inaccessible areas quickly and economically, which provides up-to-date data, helps in early decision making procedure, which reduces the field time and improves safely, and then supports GIS integration of multi-criteria analysis. So the your answer for that question, which will be exam oriented point of view and application point of view, where the marking scheme for that likewise. Stay tuned guys, happy learning.